Thank you, everybody, for joining us this evening.
I just graduated, actually.
Great turnout, especially for June, a nice warm night in June.
I just saw
I'm Tyler Boland, this is Oliver Kennedy, and we're the organizers. Tonight we're going to hear from Chris, who's going to talk about running Postgres on Kubernetes.
Yeah, I got to read this real quick so I can put the slide deck together. So we're supposed to...
Quick, put the slides together. I'll just throw in random pictures.
Yeah, I did do that, by the way, but not for the reasons.
That'd be a fun lightning talk.
Earlier
You
tonight,
just come up with random slide decks and you have to give them.
So I'm going to turn this off only because I don't know whether or not it's using my very limited bandwidth here.
go right ahead.
So I don't want that to be...
This talk will be posted sometime in the near future. Oliver also recently was able to upload a whole bunch of other videos to our YouTube channel.
They're currently unlisted. I just want to make sure all of the people giving the talks are okay with them being posted. But
I see them.
well, you see them.
Oh, maybe I see them because, yeah, okay, fair enough. Snacks, swag, drinks, help yourselves, and we'll be able to hang out here for a while afterwards if anybody wants to socialize some more. So thank you.
Chris?
It's all yours.
Thank you, thank you, thank you. So this is all you. So I want to thank Mr. Oliver for letting us use these wonderful facilities here. This is supposed to represent all of you folks. I'm excited about Kubernetes, Postgres. I really like this person right here and this person right here. They are so excited about Kubernetes, they can barely contain themselves. So normally this is the part where I introduce who I am. Nobody cares. My name's Chris. You all came here for this stuff. Postgres, containers, Kubernetes. So just kind of show of hands, curious. Who runs Kubernetes in production? Crap, I'm going to have to know more stuff. Who runs Kubernetes to play with it? Cool, cool, cool. Mr. Allen, you play with containers yet? This slide is for you. Okay. Okay. So have you played with containers yet?
Oh,
no. Any questions? That she's got answers? All right. And who here has used Postgres? Know of it, have used it in production? I like it, I like it, I like it. All right, so about 1/3 of you are in the right presentation. This is kind of a, whether you realize it or not, part 2 of a lab that we did under the old Buffalo lab group that we had. And we, at the Stark & Wayne office, we had a lab where we brought everybody through Kitematic. The goal was, or Kitematic, I don't know how you pronounce it, whatever.
It looks like a little kite.
That Dockery thing. That was the GUI for the Dockers. So my goal, and I think we were relatively successful, everybody walked out with a copy of the stupid thing working on their laptop. So the whole point was, let's just show it real quick, see if we've got enough internets here. Let's see if I must have, oh, no, it's right here. So this is Kitematic. It's an awesome thing. It's a GUI on top of Docker, so that if I want to go get Postgres, if I can spell it right, it'll go out there to the marketplace. Hey, look, here's a Postgres. I want one. Please don't download. I don't have that much bandwidth. Thank you. All right, had enough of the cache. So what we got here was a Postgres container. And then inside of the little tool here, we can run an exec. Where are we painted up? And we get PSQL, connect to it, Postgres, Postgres, select one. Postgres, ladies and gentlemen. All right, so we're caught up from where we were with Kitematic, however you're pronouncing it. Again, you're getting this adorable little Docker container. So we move on. To Kubernetes. Why? Because. So Kubernetes in the last 5 years, very popular platform for running Kubernetes, for running containers, scheduled, doing all the things that you want an orchestration, a container system to do. You're going to run that on servers, you're going to run that on fleets of servers. You have worker nodes, you're going to have master nodes. We're going to keep Alan awake for this. So it's a bunch of VMs, right?
No, it's not.
I
I just tell you that.
So,
This is Popeye the software.
so anyway, there's a bunch of different flavors or methodologies to get Kubernetes out there. There are some production-worthy ways of doing it. And then what we have here, Minikube, is the non-production way of doing it. I just want to run it on my laptop. So just like before, when we had Kitematic, whatever it's called, where we wanted to run Docker containers locally, this is a similar tool. This is giving you a little Kubernetes inside of a VM. It's right there. I promise, it's right there. So there's a little I know Alan's going to ask me, no it's not. And I'm going to show him that yes, it is indeed a VM that's right here. It's using 2 gig of RAM.
All right, can I pick it up?
Yes. So it is a VM that's going to be running underneath. And all Minikube really is I'm taking all the different components that are out there in Kubernetes land, and I'm cramming them all onto one VM because I'm going to use it as a local development environment. So there is a website where you can go get Minikube. It is a happy little website. It is a Git repo, Kubernetes Minikube. It'll bring you through how to install it in whatever flavor, Windows or Linux or Mac OS or OS X or whatever it's called this week to get it installed. Did you do so? So in my little land here, no fair cheating, you're getting ahead. Minikube start. Once you get it installed, it is that simple, ladies and gentlemen. It's going to go out in the background, it's going to do a bunch of stuff that you don't really care about, but it's going to get Kubernetes installed on your box locally. An important thing while this thing is spinning up, it's got an IP address, 192.168.99.100. We're going to need that IP address later on because we're going to want to talk to Postgres. And Kubernetes, remember, it's a container orchestration system. And it's going to mount these containers inside of a VM or a physical box or whatever. And to talk to those containers, it needs to go through the VM, so it needs to go through the host layer. So when we talk to Postgres from my laptop, and this is a little convoluted, from my laptop, and I want to go all the way through, I need to be able to talk to this VM right here. There's going to be some ports that we're going to have to run. Oh no. Please don't pull images, we don't have bandwidth for that. Okay. All right, so this little beastie is up. So that I have nothing up my sleeves, we're going to have a watch statement that's going to run down here the whole time. kubectl get pods. For Mr. Allen, what a pod is a collection of containers that are logically grouped in a deployment.
Like whales.
Like whales.
Whales.
Star Trek, whatever. Yes, we need to save the whales.
No. A whale group is called a pod.
Is that actually the name?
That's
I
why.
don't fucking make things
That's
up.
why
Come
the
on.
Yes, you do! Yes, you do! This is all lies!
That's why the logo.
No, but the pod thing could very well be true.
It is.
Don't discount that. Alright,
It's all
so
whales all the way down.
It's eternal. It's all shit.
this is more just showing I've got nothing up my sleeves here. I have no running containers, I have no running pods that are out there.
Oh, yeah, that's right. Okay, that's what makes sense, yeah.
So, how do you run? There's no F5 in Mac. Okay. All right, so we're going to start with quite literally the easiest way to get Postgres running the most dirt simple way possible. So, back when we did Kitematic or Kinematic. We basically selected the one we want, and we hit apply or start or give me one or whatever the button was, and we got one. There's no additional configuration that we needed to give it. We just got one out the door. So that's what this little command is right here. I quite literally want, I don't want to move that. We're going to run that here. All right, so let's break down what this command actually is. So, kubectl. This is the CLI that you're using to communicate with Kubernetes. Instead of a nice little clicky little GUI, there may be one for Kubernetes. I haven't found it yet.
There's a Minecraft interface for managing
Right.
Kubernetes.
So a little truth in advertising here. I've been using Kubernetes for a grand total of 2 weeks. I am not the original presenter for this. I'm a substitute presenter, so if it feels like I'm making it up as I go along, I was yesterday. We may not get to all of the advanced topics that maybe you were hoping for, but at least we're going to get you a good foundation for where I'll do the next talk and pick it up. But here, the kubectl command, we've got, again, this is the CLI in order to talk to Kubernetes. Run PG. What this is going to do is this is going to explicitly say, hey, I want a deployment in a pod, and I'm going to call it PG1. Replicas means I want one of them. And the image here, just like when you were browsing for your Docker container that you wanted, this is the name of the Docker container from hub.docker.com. Or Docker, whatever the Docker registry is. So we'll run that. What you'll see down here, there's a pod starting up. It was that fast, ladies and gentlemen. Yay. So now we have Postgres running. Forgot what I was going to show next. I have Keynote for that. All right, so let's connect to this little beastie. We know the name of the pod is this. So everything you want to do is a kubectl command of some sort. Exec -it. That's. All right, so I have connected directly to this happy little container right here. We are on the box. So if I do a PSQL -u Postgres database, select one, 'tis alive. We have a Postgres database. It is here. It is inside of Minikube, which is on my laptop.
Connected to the
Yes.
pod or the container?
I am connected to the container. Have to be on the container.
So get pods just gives us all the containers.
Get pods is getting you the. I have more than one. So within a pod are several containers. I know that. Yeah, why the hell does that look like that? Again, week 2.
No worries, I'm sorry.
No, all good.
I think it would be the pod that you're connected to, because if you had a sidecar container running on that pod,
Oh, otherwise I'd have
Then
to add
you
the
could
dash
connect
C
to it,
and then
too.
connect to that container. Since there's only one, I'm guessing this works because there is only one container running inside of this pod.
Can you say-
What's
Hey,
that?
Weibel?
Yes, yes, yes. Yes, hi.
When you say container, is that running on? Is that a Docker container or a VirtualBox?
It is a, so maybe showing VirtualBox was confusing things. It is a Docker container. So this command right here was spinning up a Docker container. I have the image right there. That's not like an isolated image or anything like that that you would have spun up in VirtualBox.
and it's not limited to Docker either. It could be Rocket.
Or run C or run V or.
Yeah.
Garden Privacy, one of my more favorites. You know, it's tomato and
Docker's
carrot,
just the most
basil and.
So the container's running within.
What are we talking about?
The hypervisor.
It's slightly off.
I'm really hungry, I missed dinner.
VM is just to demo.
We
Yeah,
should
so
have
think
done
of-
that.
Think of the VM as like a Linux box. then inside that Linux box, you just run it in the container.
What's going on? Why?
Or two.
I mean, is that just for demo purposes or?
This is because it's just Minikube is this thing that has like it's a virtual machine, and then he's running the containers in that.
I don't know, there's a turtle underneath that one.
Right, and it is, if you're a fan of Terry Pratchett, it is turtles all the way down. Yes. So,
No, that's under Postgres, right?
that is awesome.
But only if you've got 4 Postgres instances.
Right, standing on the top of the Oracle. So,
Last invention was cat play. His last science fiction invention was a cat play in Rockville, Maryland, but it's all Washington Science Association.
okay. All right, let's pick back up here. So we did our one-liner in the command line with the kubectl command, and we only gave it like 3 parameters: the replica count, the name, and the image. There's a lot of stuff that was hidden from us when we did that. What is all the stuff that was hidden? Well, there's a kubectl command to show us all the stuff that really happened behind the scenes. Let's get out of this. All right. So, yummy, yummy, YAML. You can, I don't know what the best way of describing it, but this is quite literally that, that pod or deployment that we just did. These are all of the fields and properties and everything else that got set up that were defaulted in for us, that we automatically got for free. It is very good about figuring out how the best way to do the world. And there's templates and specs and labels and images and bearers, oh my, all sorts of stuff that, dear God, what is in here. Again, the good thing is that we saw from that simple command line of that kubectl run, I didn't have to know any of this, it just defaulted it for me. What happens if I wanted to supply more of this information? What's the label, then namespace, whatever in God's green earth self-link is. We're going to wind up with a command line that's going to scroll page after page after page. It's going to be completely unreadable. So kubectl also has the ability to read YAML files, which is really good, because that's what this format is right here. So that means that we can also create a YAML file and deploy it. Again, we don't necessarily need every single stinking one of these properties filled in, because as we've seen, it has the ability to fill those in for us. So I have taken and mpg1.yaml. I've taken that one-liner and kind of made, this is the YAML equivalent, a real basic version of it. I'll take, I want that. Again, we're gonna give it a name. We want one of them, and this is the image, but we've got a couple extra things here. One is the default port that we want it to run on the inside. I don't know why in the world I have these commented out, but I want them.
You can hit the X key and just delete the character under a cursor.
Or you could do a switch.
I am so used to using Visual Studio Code at this point that my Vim skills have definitely declined. I will completely admit that. All right, so we'll save that. And if you want to, instead of the run command that we have right here, where we passed in all the variables to it, we can simply use ctl. Apply -f, which just means I want to read in a file, d1.yaml. Now there's 2. Now there's 2. Isn't that cool?
And they're on the same port internally.
Internally, they are both listening on port 5432 within their own containers, which is completely fine. When we get to exposing those services on the underlying host, we won't be able to map both of them back through port 5432. We have to start making some decisions about who gets to win. All right. Where was I? Go right here. All right. So, really, really cool. We've got two Postgreses out there. There is there was the PG1 and there was the PG1B. 1B being the second one that we did. But right now, the only way that we can connect to those is by execing onto the container or the pod. We haven't figured that part out yet. And running PSQL from there, connecting locally. That's freaking awesome. That's really a pain in the butt to actually get data into it, to hook it up to an app, to expose it to the outside world, whatever it is that we would normally do with a database. We're not data hoarders here. So we need to be able to expose these Postgres services to the larger community. And there's two ways to do that. The first way is this kubectl expose command. What that is going to do is you are going to map and I don't need this anymore because we put that actually back in. Now I know I commented that out. But this node port, what that's going to do is it's going to mount a port through to the underlying host, which in our case is the Minikube VM. And the one that I want to expose was the one that we named PG1, which is the first one that we did. So I'm going to go in here. I'm going to try to do this without moving everything around. All right. What did that do? If we run a kubectl get services, I shouldn't have the Minikube one there. Here was the PG1 that we had to find. It's as a node port. It internally is listening on port 5432 inside the container, attached to the host at 32100. That's awesome. That was randomly assigned. I got a nice number like that. So we can, from the laptop here, not inside of the container, not anywhere else, we can -H. Oh, crap. What do I need to connect to? Well, it's not the cluster IP. That's not the beast we want. External IP is not populated. We go here. What goes here is the IP address for the Minikube host. How do we get that? There's 3 different ways. When we started it, when we did the Minikube start, it spit out the IP address. If you're forgetful like me, Minikube status. And we'll just spit it out for us. Isn't that cool? There's the IP address right there. So when I do the PSQL-H, I now have the IP address I need. And the other bit of information we need is the port, which is the 32,100 here. So now we can go ahead, PSQL -H. 6, 8. I missed my number pad. 100 ports. 32,100. Postgres. Use the keyboard. So this is connecting from my laptop through to the Minikube VM and tunneling into the underlying container, where I can do a select one is always proof of life. Postgres is alive, it returns back the number 1. So that's how we're doing our mapping through. So we ran this command to expose that service all the way through. Just like everything else with kubectl. Hey, I bet you there's a YAML way of doing that. Wouldn't that be cool? So let's take a look at services. The name of the service was PG1. So we can cube, CTL, just edit. Service, name of service. So this is all of the YAML that was created for the service. So inside of this, we've got some labels, some namespaces. The important part of it is this is where the mapping is taking place that we've got defined. So the node port was 32100 is a TCP, and it's going to bind back through port 5432 to the BSD on the inside. Some more stuff here we'll cover in just a little bit. So with that being said, there is one more way of, if you don't want to guess on getting the port and the IP and all that other goodies, Minikube itself has a little extra bits in here. This will be the IP address and the port that you would connect to get to this Postgres instance.
Can you just copy with the right mouse click?
Yes, you can copy it with a right mouse click, but this isn't in the format, because you need to take this information here and turn it into a PSQL statement like this one. So this not equal this. So you have to transcribe. I need this for my port. I need this for my host, and then you can connect through. As far as the username and password are concerned, that was just built right into the Docker container for Postgres itself. There's always a Postgres database called Postgres, unless your DBAs hate you. And in this case, there is a default user called Postgres that doesn't have a password assigned to it. That's why we can connect them to it. All of those things in a real production grade system, you can make changes to stuff, harden it, do all those things. All right, so back here. On this one, I didn't have a cute little picture, so we just got the default one. So we looked over the service that was created for PG1 with some YAML. That's what we looked at. The next thing up, so we're going to create really the third example, but we're going to call it PG2. We'll show you how we add that service YAML directly into the deployment YAML that we had. I'm going to use this tool instead. You can make it bigger. Not that big. All right. Can we see this? Looks much better than the block. All right, so this top part here, we haven't changed between PG1 and PG2. For the most part, I don't know why that's lining up just a little bit different, but please trust me, there really is not much of a change between those two. The difference here with PG2 here is we've come down here and we've added this kind. This is the resource type inside of Kubernetes. It's called the service. So we're going to define that service. And the cool thing about putting both of these in the same YAML file is I don't have to run multiple kubectl commands. I just define what I want the whole stinking thing to look like in one YAML file, feed it into the kubectl apply, and it will do all the things I put in here. So I can keep adding different types of resources and whatnot inside of this, and this becomes one giant definition of how I want the world to look. Something important here for the service is line 37. Line 37 right here, when we define this service, the service has a name and it's got some attributes and whatnot here. I've got this commented out because if I don't provide this, that will automatically dynamically generate the port assignment for me based on what's available to the underlying host. But the important part here is for this service, what it maps to, it's based off of this label right here, this selector. So the run PG2B matches the label that's up here for the spec for the deployment. If these two don't match, it doesn't know what to link them together with. So let's go ahead and deploy this pg2.yaml. If we do a kubectl get services, we'll see that the little sucker is already registered for us. We didn't have to do that separate kubectl expose command. So PG2 now is living at 3740, so we can connect in with our happy little command here. PSQL command 040. And we're in. Yay, crowd goes wild. That was your cue. Woo! Cool, cool, cool. All right. This is fun. Persistence. Why, you ask, is that important? In the current state that we've deployed everything, it's stateless. Now, what does that mean? It means if I delete the damn thing, it just goes away. So much more fun to show a demo of that. So if we do a create table, pickles, one of the best foods in this world. Jar int, we've declared a table, and we are going to put one pickle in a jar, insert two pickles. I don't know where I'm going with this analogy, but values one. You put one in. Select star from pickles, my favorite queries ever. And we have one pickle in the jar. That's pretty cool. I love it. Keep an eye. What's this one right here? Something that'll make you shudder a little bit. Delete pod. Generated. But we define it that there should always be one running. So the scheduler, even though we just kicked it in the teeth and said, you're out of here, the scheduler went, hey, no, I'm supposed to have one. Okay, so it put one back up. Let's connect back to it. So sad. My pickle went away. What happened here was, since I didn't have any persistent disk or any other solutions underneath, as soon as I kicked the disk out from underneath the pod, what we got here was a new pod with a new ephemeral disk underneath it. We've lost all of our data. This is making your DBA very sad because one of the important things we have not done yet is scheduling backups. So we lost our entire pickle jar. So sad. So that's where, oops, this here, SQL will poof. That's a rock from my desk. I was doing Google image searches and I got frustrated trying to find what I actually wanted. So from here on out, the images are all my own. So to take care of this problem is something called stateful sets and persistent volumes that we're going to leverage both of these to make our disk and the pod itself more resilient to change underneath. So I have created an adorable little deployment already for us. All right, so back in PG2 here, this top part here, the kind was called a deployment. So this deployment was giving was basically a wrapper around the container definition that was here. The stateful set that we're going to use not really that much different, but the stateful set lets us hang some persistent disk on it. So the stateful set that we've got here, again, it's still got a spec, it's still got a spec for the containers themselves. This stuff hasn't really changed. Hold on. This stuff hasn't really changed much, other than a couple labels, just because I can't reuse the same labels over and over again. There's a uniqueness that's required. So what I've added here is, down here is a persistent volume claim template thing, stuff, whatever it's called. The important part here is I've declared that I've given this thing a name. So I've got a 1 gig disk that has the ability to mount to multiple nodes. Not that that's necessary to go into here. And this is what the name is. So I can take this disk. This disk is going to get created independent of the rest of the world. Whatever pods that are out there, this thing will exist as a 1 gig persistent thingy. I'm going to take that thingy, and that's what volume mounts are right here. I'm going to take this thingy and I'm going to associate it with this stateful set that's right here. This is how I do it. And this is where I want that to mount. I don't want the whole stinking image to be on my persistent disk. I know a little bit about Postgres, so I know that inside of Postgres, my data folder is there. That's where, I don't know, Tyler can go into this more, but there's the data E things where the tables and stuff actually live are in files that are in that folder. Do I have anything else to say about this? No. Let's run it.
Where is this? Persistent where? Is it in memory?
It's here. This is the best place of all. All right, so.
I expect I could pound on your chest and hear the Tin Man.
All right. So I need a kubectl storage classes. All right. So inside of.
Am I screwing you up? I guess.
No. No. This guy back here is giving me that. Because, okay, so every Kubernetes deployment that you're going to put out there that you'll eventually put into production or actually let anybody use is going to have storage classes. And what these storage classes are is they'll correlate to NFS storage or node storage or node path or node, I don't know. There's storage that's on the VM itself. There is storage that can be NFS mounted. I'm guessing you can do SAN and iSCSI and all sorts of other stuff. I haven't explored that far yet. The basic idea is you're going to want some sort of shared storage because in a production you're going to run multiple worker nodes. So all of those worker nodes, you don't know where the pod is going to live. Love. So you have these different storage classes available that are going to map through. Your persistent volume claims are going to be associated. You're going to pick one of these storage classes to deploy against. Inside of Minikube itself, we get one by default. It's of type host path. That means I'm going to get a disk, a 1 gig disk that's provisioned inside the VM. Nothing you would ever use for production because as soon as you delete the VM, that disk is also gone because you provisioned it from the inside. But this is more of a, when you combine the stateful set with the fact that you have a persistent volume claim, this is getting a little ahead. When we do the delete, it's not going to delete the underlying disk. It's going to keep the disk out there and wait for the next pod to come up, and that's going to reattach the disk, is what's really going on. Where if we just had a regular deployment, it just gets rid of the disk every single time. It's just throwing it away. So yes. Did I answer your question, or did I just make it more confusing? Only half of that I made up as I was going along.
Please continue.
Okay. All right. So we're going to take our example that we were going through in here, which is our first stateful set example. It's going to have our persistent volume claim, and we're going to mount it all the way through. We're going to see what that looks like. Container's going to create. This time when we go to look at the service, we're going to notice something that's just a little different because we're using a stateful set. No, okay, sorry. This is what's different. So you'll notice here, when we did our very first deployment, we just called it PG1, and then it added some garbage at the end of it here to make it unique. When we do stateful sets, as opposed to deployments, this is a fixed name right here, and as you have more and more replicas, this number will index up 1, 2, 3, 4, 5 to kind of match. So this gives you, you're always going to consistently know the name or the DNS resolution of where this particular one is, simply by the name and the index.
Is there anything that prevents you from standing up multiple instances talking the same shared storage?
One more time? Sorry.
Could I have more than one container attached to my shared storage?
Yes.
Is there something I do to stop that from happening?
So within a pod, they all have the storage available to them. That's actually listed as a feature for Kubernetes, not as a detriment to Kubernetes. From pod 1 to pod 2, they can't see the disk. So once a persistent volume is associated with a particular stateful set or a particular deployment, it can only be mounted to that particular set of pods. So if I had a second deployment or a second stateful set that did not have that persistent volume claim to it, it would not be able to read that first pod's, wouldn't be able to get access to it.
Would the exception to that be if you had an NFS storage class, where you would want to share that volume across multiple pods?
If you wanted to share it across multiple pods, I haven't done this part
Sorry.
yet.
I'm kidding.
I believe, from the book I read, I believe you can. It's just you have to declare the same one over and over again. So that the persistent volume claim would have to give it the same name from the stateful set 1 to stateful set 2 that you had declared and used. That sounds right enough that I'm going with it.
I'll go with it.
Okay.
It seems like you ought to be able to lock that down with some sort of security. So even if you know the name of my persistent volume claim, you can't attach it to your set of pods for safety. Maybe it's not even nefarious, it's just
Yep.
safety.
So one of the ways to keep everybody in their own damn bucket is the concept of namespace that I'm not showing off here. And what namespace is you can think of it as, for the one other person that knows Cloud Foundry here, it's the equivalent of an org. So that if you have a business unit, say I have 2 business units, A&W and Cheetos, all owned by some conglomerate somewhere, PepsiCo. So I have the individuals that belong to A&W, I have the individuals that belong to Cheetos. I will create namespaces inside, and let's do that. Let us do kubectl, create namespace. Cheetos? I don't know, I'm making this up as I go along here.
Yep.
Cool. So if we add Control C here, and we're gonna add on the namespace. Let me show what just happened here. So CTL get namespaces. We have a couple namespaces here because I was desperately trying to get an operator to work that never wound up working. You'll never guess what the fault is. It's the default one you get if you don't name. We just created Cheetos. When we were deploying, when we were doing this watch command down here, and we were seeing the pods that were active, what we were looking at were all the pods that were in default, or the default namespace. So that's where those happy little ones are. If we were to look at kube system, this part hurts my head. Kubernetes itself runs inside of containers that orchestrates itself. Ouch. So the etcd and core DNS that's on the inside, where's etcd? I don't know why it's not there. Maybe it just scrolled off the screen. Anyways, so there are a bunch of containers that you're not seeing because we're looking at kube system. If you wanted to look at nigh all of them, CTL get just all dash namespaces. I want to see everything. This is quite literally everything that is running on this particular Kubernetes cluster. Cluster in this case being just one. So in the default namespace, we've got the 4 that we had before. Kube system, we've got a bunch of pods, and PGO, which is a crunchy data Postgres operator. We've got the 3 pods running in there. I forgot what the heck the question was. How did we wind up here?
You have Coke and Pepsi on the same machine.
Coke and Pepsi. All right. So
It wasn't me this time.
So we would do isolation to keep everybody away from each other. Cheetos would get a namespace. You deploy the pods over there. Once you're a member and once you've logged into Kubernetes, right now I'm in as God mode or administrator. You wouldn't give somebody else that rights. They would have rights only to that namespace that they were in. So they can only see persistent volumes are associated with namespaces. Pods are associated with namespaces. So you're only going to see the pods. You're only going to see the persistent volume claims. You're only going to see the storage accounts. You're only going to see the service accounts and whatnot for your namespace. So that's how I keep Pepsi from attaching to my damn disk and swiping on
That part again, I'm much more worried about me tripping over myself and starting up another Postgres instance on top of the same shared storage that another one is already running on.
Don't know.
And that would be.
But I look at it as a feature that's going on 2 web servers.
So you
Because I
wouldn't
wanna share
run
that.
2
Let's-
Postgres is within a single pod.
So you separate.
You would run 2 pods.
Right, you would run separate deployments.
And so
deployment
within-
is to a pod then? Is that how it's like that?
What's that?
Like, what's the relationship between a pod and deployment?
Magic marker time!
You should probably use dry erase instead.
Yeah, that's true.
Don't we have yellow
I
ones?
have my erase if you'd like some.
Oh, come on, I've always got them. They're always in here. Can't go to California without them.
Appointment.
Anything.
I guess what I
It's not picky.
Black, blue, and green.
Awesome.
People walk
Thank
off
you.
with theirs.
All right.
Remember where you got them.
I've yet to see
Sure.
a marker survive.
All
more
right,
than
so
2 days.
you've got a container. And we're going to put the word Docker here. So more people know what that is. I got a Docker container. I got another Docker container. These live inside of a pod. And inside of that pod, all of these little beasties can talk to each other over a local host. So this one could be listening on port 5432, and this one could be 4443, could be an Nginx or something like that. When these 2 little buggers are talking to each other, because a Docker container is nothing more than just a file system with a process running in it, they can talk to each other over localhost. They also, my understanding is there's the ephemeral disk that's down here. They're supposed to be able to attach to that as well. If you have some persistent volume claims, I love so many colors. The persistent, okay, and then these exist within a namespace.
That makes a lot more sense.
What
sorry,
should-
this
Oh.
inside of a deployment,
Then inside of a namespace?
a deployment or a stateful set or a daemon set, or there's like, I don't know, 6 other different types of,
Do any
I
of
think
those
this is
things
really called a daemon set.
span pods?
What's that?
Is a stateful set limited to being one pod?
A stateful set can be multiple numbers of pods. So if I were to take with the stateful set,
I really wish Dan was here because he'd be able to explain this so much better.
I'm sorry if I'm derailed.
No, you're quite fine. Inside of here, I should have replicas.
Yeah, I saw it earlier. Replicas 1.
Whatever. Yeah, there. Okay, so let's take this.
So let's say I was just an idiot and I put replicas 2,
All right.
They
and I
would
had
still
that
be separate
same
pods.
volume, I would be nuking my stateful storage.
Let's do this. Let's have some fun. All right, we're going to redeploy this little sucker.
Postgres should be smart enough not to start up a second.
It is not. It is not. It is not.
But they're, so it's a replica refers to
No,
spanning
because
power.
I will show you what's going to happen. I will show. Oh, this is fun. I will show you what's going to happen here.
Which is what a
Postgres,
That's all.
using the same volume claim.
Yeah, but
Sure, it's
Postgres
using the
should-
same.
shouldn't
Okay,
let
go
you
ahead.
open 2 copies of the same data directory.
Okay, so if this was a
It's controlled by an
deployment,
OS instance.
Okay.
If you're outside,
the answer to this, if this was a deployment and not a stateful set, it would spin up 2 pods, pod 1, pod 2.
forget the persistent disk for a second. And this one doesn't exist. So we've only got one container inside of it. And it's at 5432. And we have a second container in here. We're going to call this D2. We'll call this D1 for pod 1. What's going to happen is, because we have the service exposed, the service acts like a round-robin load balancer. So in front of this, there is a service that we defined called PG1. When you come into it from the outside world, connect. The first connection will go here. I'll do my select statement. I will do what I need to. I will come out. So it is mapping whatever the 32100 was to 5432 here. That's cool. Goes and does the second connection. Routes it here. 1, 2, 3, 4, 5, 6. Guess how much fun that is going to be. Where'd my insert statement go? But the create was over here, but the delete was over here, but the update was over here. This is really good for things
Pod
like
lines who can't talk to each other?
Nginx or something that isn't stateful. You'll want to do this. When we get to stateful sets, with what you're talking about, if both of these connect to, and I haven't done this, so I don't know truthfully what the hell it's going to do. If these both connect to a happy little disk over here, I don't think Postgres is going to come up clean, because both of the PIDs are going to try to connect to that disk, and I think it's going to go no mas.
Or the first one wins, or something.
Or the
Yeah.
first one wins, or yeah, the
That's what I'm assuming.
the postmaster, the
Postmaster got PID.
is only one of those is going to win.
Yeah,
Let's go find out. I'm really
They should
curious
take a
about
lot
what
of
it's going to do.
in principle, if you're running 2 copies of Postgres, only one of them should be able to take the lock file.
Okay.
so it's log file dependent.
Yeah.
So
So
as
as
long as the
long-
log file is in your data directory, it should be okay.
Yes.
And if it's
And as long as
wrong,
the log
rather
file
than
actually
wrong-
transitions the boundary.
Yeah, we got replicas 2 here. All right, so this is this one.
Experimentation did.
I'm just going to close this because it's annoying. Let's deploy the little sucker. And
Now, will the service
Now it's
die if
generated
Postgres
another.
dies? Like,
Well, it should say there was.
It's generated.
1-0 and 1-1.
Yeah, generated another.
All right, so let's connect to each one of them.
Would the container die if Postgres dies?
Let's find out.
And this is with a persistent volume, right?
Just double check that we've got it. Yep. So both of these beasties should be attaching this volume to this mount point right here.
Can we, is there a kube control right with that?
That actually answered my question that I had before.
So what I want to do here is I want to connect to each one of these containers. Is that
Dash. Oh, no, that's just.
single? All right. Postgres.
Bless you.
I can't make it bigger because then everything's going to resize and just squint.
Oh, yeah, just squint you.
So I've just connected to the second container that's out there. So let's start from table 1. Doesn't know what table 1 is. Interesting.
So is it doing something unique with the path on each?
That's pretty,
Underlying
I don't know what the hell's
persistent
going on.
Can
I would have assumed that this one would have failed, could have started up the second one here.
What happens if you look at the files in the directory of each container?
Right. Their ages are different.
Yeah,
I got
because the
part of
one
the
didn't have to
data in my
change.
head.
we
What
just
is it?
Added a new replica.
You mean this?
Yeah.
Yeah.
Yeah, so Kubernetes is kind of smart like that.
We'll
So it
just
didn't destroy the first one, it just.
It just says, oh, my state, and my
And you just
number of
see
pods will
mounts
change.
too.
It's already have 1, now it's 2, I'll just run 1.
Oh, that
How the
doesn't
pit
have.
is in there?
Okay, so.
What are you looking for?
I was wondering if you could see how you're mounting it, just like mount, from mount,
What command are you looking for?
enter. It's doing it as SDA1.
Where do you see?
Try it.
Try just-
4 lines down from the top.
touch a file in there?
Yeah, touch your file. See what happens.
Demo.
I can't imagine you're seeing it over there.
No.
Yeah.
All right, so let's see if.
Not like that.
Same file.
CTL. PVC. Okay. Yaha. All right. Let me do it over on this screen so you can freaking see it. What it did. Sneaky little butter.
Same volume. Different namespace.
It created
Oh, what is it?
2 of them. One for this one for this one. And I know this because the volume names are just different right here. Oh. All right, so the persistent volume claims are not shared across.
It's not an configuration.
At least not in this computer. They are mounted to the individual
Except that's not the symbol for disk. But
Okay.
you all know what I mean.
So I guess maybe this leads into my question I've been kind of holding in for a second. So these volumes, now I think when talking about you can mount a host directory to a container directory, like a similar cross. Are these actually like a single file that's all gets written to, or is this data actually exposed on the host?
So if we go up into the, how the hell would we get there?
You have to be on the Minikube and.
Yeah, you'd have to get on a Minikube, and yes, they should be listed. From the host, you can see down. From the container, you can't see up,
Right.
which is the privilege.
So if you went to the host though, you would see like demo.hi
Yeah, I've done
somewhere on the
this.
file system.
Right, when I've
Okay,
done
so
this,
okay.
when I've done this as a CFCR deployment or using Bosch to deploy Kubernetes, when I created the node host path, host, whatever the frickin' one is where the disk is on the host, yes, you could see down and you could see the file structure all the way down. I don't know how the hell to emulate that in Minikube, and we all want to go home tonight, so I will. Turtles all the way down. Thank you for this. Do we have any pending things that we haven't, questions that we haven't gotten to? I've been meandering, so I don't know if I'm answering all the questions or not. Going once, going twice. All right, let's see where we were in here. All right.
Cube has an escalation.
So we had started.
Good.
The hell is it? Oh, so if we had. So, we got pickles and all sorts of stuff in here. So this is the stateful set, the first stateful set that we had created inside of this Postgres database. I got 2 tables created. If I were an evil little bugger.
Chris, are they on the same server? The 2 tables should be.
Well, now there's a loaded question. On the same server, they're all on my laptop.
Okay.
So
they are all
on the same VM.
they are all sitting in the same VM, and that's only as a consequence of me having a laptop that is a single physical beam.
Okay.
In the real world, when you've deployed Kubernetes, it would be deployed to 10, 15, 20, 90, 100 worker VMs. But the
Each
pods
pod.
would be distributed across those nodes.
Okay.
So across those VMs. They could be physical boxes or they could be VMs, depending on how they were provisioned.
But pods are atomic. They can only be, one pod belongs to only one.
Yeah, well, very specifically, if you've got 2 containers inside of a pod, the pod cannot be physically split. If this was a server and this was a server, you can't wind up with a container here and a container here. Now you can wind up with pod here if you had replicas too. That's fine, that's not going to break anything because your internal networking is still fine, your ephemeral disk is still fine. Our persistent volume claim, as we found, will be fine when they're separated, but the containers themselves have to be always on the same node inside of a pod. All right, so again, stateful sets. We have some persistent disk here for a given value of persistent disk. And we had 2 tables that we had created. If we do a cube CTL, pods, I forgot the name of the stupid thing. That's this one. And we're going to do the same little experiment. I need another window. Well, we'll just do it here. Cube, CTL, delete, pod. What we'll see, it terminated it. It's going to bring it back up as the same name. We go back into the little beastie. two table still there. It's not what happened to us on our deployments, and we can select pickles, assuming we put something in the jar, I don't remember, we did. All right, so, took us an hour and a half, but we got through this slide. We only got, in reality, one more slide that's got anything in it. This is my pet lobster, Pinchy. I got him from Boston a couple of years ago. He's watching you. He's keeping an eye. So, just like anything else in this world, you want to make sure that your container, your car, your dishwasher continues to run. So there's something called a liveness probe that's inside of your pod definition. And what that is doing is it allows you to perform a test. If the test fails, I'm going to restart the pod. If the test passes, I'm going to do nothing. So, what do those tests look like? We have an example, believe it or not. Y'all are so excited at this point. Stateful set example number 2 here. The only difference between this and the first one is I've indexed the number 1 to the number 2, and we've added this liveness probe that's here. So we'll go through this a little bit. So I said the liveness probe works against a particular pod. That's why we're inside of this container section right here. This section right here, what this is going to do, again, because all of our traffic is local to the inside, I don't need to know an IP address or anything like that. I can just connect natively inside of it. And I'm going to select 1 when I make this connection. So as long as this command is able to connect to the database, select 1, nothing else is going to happen. There's 6 or 7 different options here on different parameters you can set. The 3 I've chosen here is it's going to wait 15 seconds for the container to come up the first time. This is the frequency. So you can, and this is in seconds, not in minutes like cron is. So this will quite literally run this command every 10 seconds. And I'm not entirely sure what the timeout seconds is. I think that's if it will try for 5 seconds to run that command. If it's not successful, it will give up. So let's go ahead and deploy this. That's what we do. So we've got, that one just came up and alive. Well, this isn't going to be real interesting because we wrote a select 1. When you wait here long enough, it's only Thursday, Friday. This restarts is never going to change because this actually works. So to show this little beastie working, we actually have to break and make bad change to the command that's going to run. So the easiest way I can think of this is there quite literally is no database in the world called that. So we'll save that.
Are you sure?
Could be Unicode.
Is that a challenge?
Sure, there's some jerk somewhere. So
There
we'll
will
go
be in a
through,
few
we'll
moments.
redo it, terminate it, bring it back up. Now we'll have some polite conversation for about 45 seconds. And what we're looking for here is that test to fail and this to index up.
The restarts?
Yes, the restarts. Because that's what this liveness probe is going to do. If it fails the liveness probe because it's not going to find that database, I guarantee it's not going to find that database. It's going to restart the pod in a desperate attempt to resurrect the world.
It's unchanged.
Speaking of, anybody know how the Blues and the Bruins are doing? I'm surprised anybody was here. It's been a good series. Stalling for time.
That's the service. That's unchanged. Whereas the stateful set with the new health.
That's on
I feel
one
like
of
you're
these
tempting the
individual
demo
models.
gods.
Oh, there you go.
There it
Let's
is.
do that. So I knew somebody was going to bring up, well, this should only be 25 seconds. And I completely agree with you, and I have no idea why that took 50 seconds. That's consistent. I don't know why it takes that long to fail. But if we were to wait just a little bit longer, it's going to get to 90 seconds again, and it's going to do it again. So I'm not quite sure how it actually adds all that up. There's some other fudge factor that I don't know about, but I encourage you to read that section on all the different parameters that it's probably providing, just at another time. So
Maybe it's not counting the container start time.
I don't have a freaking clue. I only noticed that about 20 minutes before I closed the laptop and came here, so I don't know why it's doing that.
Oh dear.
I was wondering if you have to bomb twice.
All right.
Once.
Okay.
Here's the life is proof.
All right. This brings up the issue I had before that I'm like 2 weeks into Kubernetes. That's my book I've been using. The next thing that I was trying to get is Kubernetes operators to work. And what that is we have been doing all sorts of cute little tribal knowledge where we're mounting data paths and liveness probes and number of replicas and stuff like that. But we haven't gotten down to, well, what does it look like to back this thing up? Can we put PG Bouncer in there? Can we put PG Pool in there? Can we do streaming replication? Kubernetes is not a new thing. Postgres is not a new thing. It's just we're late to the party. People have already figured out how to run Postgres on Kubernetes with more advanced things called operators or Helm charts. I was trying to get a Postgres operator to work. There's one from Crunchy Data. Struggling to get it to work inside of Minikube. I think it is way more me than it is it. But the nice thing about that is you're able to spin up Postgres clusters very quickly. Right now we've got defaults as far as usernames and passwords. It'll do all the role-based authentication, the users, who's supposed to allow them to create schemas and all that other nonsense. That's all baked into that. So what I'm hoping is maybe September or October or something like that, when I've had a little bit more time to read up on this topic, I'll be able to come back to you and say, hey, these are like 5 or 6 operators you should use. Now you should understand the fundamentals of your deployment steps and stateful sets and daemon sets and all that other stuff. But here's this kind of like pre-canned thing that you only got to make minor modifications for your particular production environment. That is not the same book. That's the Kelsey Hightower one. This one is by Safan. I don't know how to pronounce names. This is the second iteration of the book. Kelsey has got a really good series that's out there that is called Kubernetes the Hard Way. That basically what they do, they take you all the way through. Here's all the certs that you got to create. This is how you put everything. This is how you put your etcd cluster together. This is how you build the whole. So everything that Minikube is just automatically doing for you behind the scenes. If you really wanted to get into the guts and the gore, he does a really great tutorial. You use basically you just provision up a bunch of GCP resources, and then you spin up your deployment. I'm actually hoping to do that maybe next week, which is I was talking to Mr. Tyler about. Hey, how do we provision resources internally? Not that I'm trying to guilt him into letting me have some GCP time, but hoping to get there. So if you were hoping for, hey, what is the final production way to run this stuff, to run Postgres and Kubernetes, stay tuned. I don't have it yet, but we hope to the next time I do this meetup. So there's that. The examples that I had tonight, I do have up on GitHub. If you want to take a little closer look at them. If you want to get a hold of me, I'm on a couple different Slack orgs, or you can just post a question, an issue or whatever inside of that GitHub org, or Tyler knows about 15 different ways of getting a hold of me. Questions? I'm not guaranteeing answers, but I will listen to questions. Yes, sir?
Is it a good idea to containerize database
So from a performance perspective, you're not gonna get a performance hit, really, on running Postgres inside of a container as opposed to a VM. There's no penalty there, because it's just the file system that's underneath. Would I run exadata worth of, or petabytes worth of data through this? No. At least, not yet. You're not going to have, you're not going to have a persistent volume plane that's probably large enough to do that, to store that information. The first time you go and take a backup of that, you're going to blow out all the disk that was ever created, because Postgres is going to use toast compression behind the scenes. So it's probably going to pack your data down about 92%. First time you do that backup, it's not compressed. So you're going to eat up all your disk. Plus stuff that is that large, if you wouldn't run it as, if it's too big or too complex or too nasty to run it on a dedicated VM, then the container isn't going to do anything for you. So if you do need multiple nodes, you're going to start getting in Oracle rack solutions, and then you're talking in solutions that have 2 commas in what your quote is going to be from that vendor to get that Oracle solution in there for you. But at this point, I would say if you would run it as a VM, whatever size of Postgres that is, or MySQL, and I don't want to say there's just Postgres is available. There's MySQL, there's Oak Solutions, there's everything else. If it would break running on the corresponding size worker node, then it's not going to fit inside of Kubernetes either. My official answer. That's what I'm going with. I'm sticking with it now.
If you want to run a big database inside of Kubernetes so that nothing else, so that the entire node is dedicated to the pod that is running Kubernetes.
You can do that.
Okay.
Yeah, you would do, I believe they're called taints. So that basically it's like a label that you would put on the worker node itself that would correspond to a particular deployment that you would have inside of Kubernetes, and then when the scheduler comes along, it will place it on just that node. And you can use up all the resources of that node, which is why if you have a worker node that is 4 core, 16 gig of RAM, but you need more horsepower than that, there's no amount of containerization that's going to fix that resource problem for you. So you can go up to the size of whatever the node is that you're running it on.
And you could probably, depending on the database technology, you could probably shard it between pods, right?
Yes. So you could grow it across that way, but that would be the same as if I had a Cassandra cluster. I would spread that out over 5 VMs versus 5 pods. Sure, the amount of resources you would need would still be exactly the same. The amount of RAM, the amount of disk, the amount of CPU you would need would be exactly the same. The only thing that the container is getting you is the file system isolation.
Is there something that you can use to tell Kubernetes, and I assume there is, these things can't cohabitate?
Yes, there's the DRS rules in VMware.
There's affinity and anti-affinity.
Yes, affinity, yes,
Okay.
and anti-affinity.
It was confused by those
Stay on me out of that.
You can put almost a label on a node,
Okay.
and then you're gonna tell this pod to go on that node.
Well, so I don't want to tell it what node to run on, but I
Yeah,
don't
but
want my 5
With the anti-affinity.
Mongo replica
right.
set nodes running on the same VM.
Right, with the anti-affinity settings, you can tell one disk on one node and only one node. So it's the one static, it's another third cluster.
Okay.
So just for legal purposes, this is the sourcing of the pictures that weren't the ones that I took myself. And thank you for coming.